Good morning everyone, welcome back to MAC1105. In this video I just want to show you how to solve quadratic equation. Quadratic equation or quadratic function is one of the concepts we already learned in intermediate algebra. This is the last concept in intermediate algebra course, and you already been introduced to quadratic equation, quadratic function, and the standard form of quadratic equation and quadratic function also. So in this video, I'm going to go through some few kind of a quick review on the concept of how to solve quadratic equation. Then I introduce the new method of solving quadratic equation. Okay. Okay. So let's get started. Here. So I'm going to put the topic today will be quadratic equation. Okay. So on the first part of our lecture, let's see what quadratic equation look like. I know that many of you already know that, but let's do a quick review again. Definition. So quadratic equation will be in the form ax squared plus bx plus c equal to 0. Okay, in the intermediate algebra course we call this a trinomial, right? And we put the equal 0, it means become quadratic equation. And you see the ABC over here is just a constant number. Yeah, just constant, mean that it could be any number, could be fraction, could be decimal, could be positive or negative, and they could be missing one of the term, but it cannot missing the square term, because the square term tell you that an equation is quadratic equation. Okay, the square term over here tell you this is quadratic. If it doesn't have the square term, then it become linear. Okay, so you have to be careful over there. So if b equal to 0, right? If b equal to 0, then my quadratic equation, my form here. So let me box them. Become ax squared plus c equal to 0. This is still called quadratic equation. Okay, so this is still called quadratic equation. However, if a equals 0, then my equation become bx plus c equals 0. So this is linear now. Linear equation. So you have to be careful. Okay, so if you see something with square, when this is the highest degree in the equation, then that is called quadratic equation. It doesn't have the square part, then you see that it becomes linear. For example, I have something like this, 2x squared minus 3x plus 5. Okay, this is quadratic equation. Okay, we gotta have ABC, right? And how about this one? Example 2. It could be something like this: 4x squared minus 5 equal to 0. This is also a quadratic equation. Well, or could be something like this, because you see that they have the square part. So as long as they have the square part, it is quadratic equation. Or something like this: w plus 3 squared equal 8. This is also quadratic equation because it had a square part, even though that doesn't look like a trinomial, right? But just think about it. We go ahead and expand this one out. Yes, it's still trinomial. Okay, and they had a square part. That's the most important thing. They had a square part. I mean, that's quadratic equation, and the square part must be the highest degree of all. Okay, that's the highest degree. or could be some a more complicating form, something like this. And this is still, even if something like this, this is still considered quadratic equation. Okay, about this, about t minus 1 over 2 square. Okay, minus 10 equal 28. Okay, something like that. This is still quadratic equation because this is a second degree, even though that is not in the form. But if you go ahead, expand them out and try to get rid of the denominator, it become this form. So in intermediate algebra course, most of the exam or most of the problem they give you in this form. If they give you in this form, it will be easy, right? We're gonna one of the method we already learned how to solve quadratic equation. But if it is something more complicated, then of course you have to approach the problem different way, right? For example, it could be something like this: 6m plus 4 equal m minus 15. Or maybe some of you could ask me like, okay, I don't see any square thing. How come this one is also quadratic equation? Well, originally you don't have any square, right? But think about it. If we go ahead and distribute it, 6m times m becomes 6m squared. So this is still considered quadratic equation because they have the square part. Okay, they have the square part. So that is quadratic equation. All of this quadratic equation. Okay. So except for this one, this is not quadratic. To think about it, I have number 6 right here. What if I have over here b is for x, okay, and c is plus 3 equals 0. Okay, this is not quadratic because there's no square part. Okay, this is linear equation. Alright, so after we already know what quadratic equation look like, so on the second part of the video, I'm going to show you how to solve how to solve quadratic equation. Okay, method of solving quadratic equation. Okay, and we have several methods of solving quadratic equation, and two of them we already learned in intermediate algebra. So I'll do a quick review over here. So the first method, which we use quadratic formula. Well, we see this formula so many times already, so many of you still have not memorized it. Okay, we can just go ahead and memorize it. This is very important. You have to memorize it. It is the formula is x equal minus b plus minus square root of b squared minus 4ac over 2a. Okay, and this formula is working all the time. It means that as long as you have a quadratic equation, you can apply this formula unless they're asking you to solve for the solution, unless they're asking you another method to solve for the solution. Then you have to use another method. Okay, now let's go ahead and give you the example here. What if I have something like this? Sorry. What if I have okay, x minus 6 equal 3. Okay, so I have the equation like this, and if you look at it, you don't see any square part, right? And you say this is not quadratic equation, right? But it's wrong because even though originally we don't have any square part, but if we go ahead and distribute them, right? So x squared, you see that it has square part right now. Now, in order to solve for the equation must have 0 on the right hand side. So you gotta have subtract both sides by 3, then you have 0. Okay. Now I'm gonna apply the formula because a over here 1b is negative 6 and c is negative 3. Now I can apply the formula to solve for that. So it will be x equal to minus b minus minus become plus minus. Okay. B squared, so it will be b is negative 6 squared. Make sure because it's negative, you gotta put in parentheses. Okay, so because if you don't put in parentheses, it has another meaning. So b, you gotta be careful by that. Minus 4, a is what? A is 1. C is negative 3. Okay, over 2a and 2 times 1. Alright, so now you can go ahead and solve for it, calculate amount. So you have 36 plus 12, over 2. Alright, and keep simplified of 6 plus minus. So we have 48, right? Over 2. Alright, we gotta keep simplifying. So you have we need to simplify. 48 will be 16 times 3. 16 times 3, 16 square root of 16 is 4, so it will be 4 square root of 3, okay, over 2. Alright, so make sure you know how to simplify the radical. 48 is let me write over here. So 48 is 16 times 3, okay, there you go. Okay. Now we divide both sides by 2, so you have 3 plus minus, right? 6 divided by 2, 3, 4 divided by 2 is 2, 2 square root of 3. Okay. Okay. Now if what if you have the Radic Curtain is negative number, then you have to use the I, imaginary number. For example, I have something like this. What if I have let's say, what if I have this? Okay. What if I have something 2x squared plus 3x plus 5, for example, equals 0. Okay. Now I'm going to use quadratic formula, right? So I have x equal minus b to minus 3 plus minus, so 3 squared, so you don't have to put it parentheses because it's positive, minus 4ac over 2a, so over 4. Okay. Okay. So you have minus b plus minus, which is give you 9 minus 40, right? Over 4. Now, if you calculate the value under the radical, so you will see that you have a negative number. You have negative 31 over 4, right? And negative 1 right here, the negative sign over here, we gotta use the I number. Okay, so the negative 1 become I squared. So this one I can write it as minus b plus minus I squared times 31 over 4, and square root of I squared give you I, so you have negative 3 plus minus I. 31 you cannot take square root because it's a prime number, over 4. There you go. So that is the answer if you have negative inside the radical. So you're gonna use this formula. Okay, this one is the very important formula in a complex number. And the complex number is the one of the concept we learn in intermediate algebra. Actually, this is a concept before the last one. It's just one section before the last one. Okay. Alright, so that's how you use quadratic formula. I'm not going to go into too deeply because actually there's nothing to go very deeply in the first method, because all you have to do is just plug in the formula. Okay, use the formula to plug a, b, c in. Of course, you gotta bring it to this form. You gotta bring it to the a squared plus bx plus c to recognize a, b, and c. Because if not, right? For example, like this, you cannot recognize a, b, and c. So you gotta bring it to the x squared plus bx plus c form before you can apply quadratic formula. Okay. Now, the second part. A second method is that we can use zero product property. Okay. In order to use zero product property, your quadratic equation must be in factoring form. Quadratic equation, okay, must be in factoring form. It means that you have to factor the trinomial. Okay, if you cannot factor the trinomial, you cannot apply a zero product property. Okay, or you have to use G-shape, whatever you learn, whatever the method of factoring you learn in intermediate algebra. G-shape, quadratic formula, special formula, G-shape, factor trinomial. I'm sorry, G-shape, factor the trinomial, and special formula, a different of square, something like that. If not, you cannot use zero product property. What is zero product property? The properties say that if we have a product between A and B, then this implies A equals 0 or B equals 0. That is called zero product property. Okay. So if it is in the product, we can apply the property right now. If it is not, then you have to factor them out. All right. For example, let me do the first example. What if I have something like this: x minus 1, x plus 3 equals 0. Okay. You see, this is quadratic because when you distribute, they give you the x squared, so they have the square part and mean the quadratic, and it's in the product form. And because it's in the product form, we can go ahead and split it up. Okay, each of them equal to 0, and actually you're gonna use all. Okay, then this is x equal 1, and this is x equal -3. Here, if it is in this form, it would be very easy, right? or if it is in this form, what if it is x squared minus ax equal to 0? Okay, it's not in the product form yet, but we can find G-shape over here. So we factor the XL. G-shape is x. We do x minus 8 equal to 0. Okay, and from here we can go ahead and split them up. So x equal to 0 or x minus 8 equals 0. And you see that we also have to answer x equal to 0 or x equal 8. Okay. Or what if it is like this? What we have a 2w minus times 2w minus 7 equal -12. Okay, it's not in the form yet, right? It's not in the form x squared plus bx plus c. So we gotta bring it to this form. So you gotta go ahead and distribute. Give you 2 times 2 is 4. Is 14w equal -12, and add both sides by 12. There you go. So what I have here is in the form of x squared plus bx plus b. B over here is minus 14. Okay, now let's simplify them a little bit here. So I divide both sides by 2, so we have 2w squared and 7w 6 equal to 0. Now I'll go ahead and factor this trinomial because I try to use the zero product property. So I have 2w and w here, and I'm going to use 3 here and 2 here because 6 is 3 times 2. And I draw the smiley face, right? Because everybody know how to factor them, right? Using the smiley face method. So we have -3 here, -2 here, because when you draw the smiley face. So let me do a quick recall here. 6 is 3 times 2. 2 is 2 times 1. So you draw a smiley face. So give you -3w, and this is give you and negative 4w, and you see they give you negative 7w, which is the middle term. So it means that our factor is correct. Okay. So after you factor them out, now we can go ahead and split them up. So this is add both side by 3 and divide both side by 2 and add both side by 2. Here you go. So you have two answers right there. Okay. So if you if you can factor them, then you see that you can apply the zero product property. Excuse me, guys. Yeah, but the first thing that you have to bring it to this form. Okay, you gotta bring it to x squared plus bx plus c form before you can factor them. Okay. So this method is, again, this method we already learned in intermediate algebra. Let me see, I can give you another example here. Let's see. Now, what if it is like this? What if I am m plus 4 times m minus 5 equal negative 8? Okay. Now, if you look at this one, you will see the difference between example 4, example 3. You see, this one is in the product form already, but the bad thing is that over here it's not equal to 0. If it's over here is 0, if over here is 0, okay, then we can go ahead and split it up right away. But because this is not 0, so you have to distribute it. So which is m times m is m squared minus 5m plus 4m minus 20 equal negative 8. So this m squared minus m add both sides by 8 give you negative 12 equals 0. See that I always bring it to this form, ax squared plus bx plus c. Now I'm going to go ahead and factor them. So I'm going to use m minus 4, m plus 3. Okay, I factor them. Again, you do smiley method because 12 is 6 and 2, 4 and 3. So you gotta pick a pair of factor of 12 and you draw the smiley face. Make sure that end up give you the middle term. So you guys forgot how to factor. Please go back to intermediate algebra to do a quick review. Okay, or you can YouTube. It's everything there. Factor trinomial. Now I can go ahead and split it up now because it's a product and it equals 0. Okay, now m equal 4, m equal to 3. Here you go. So you have two answers right there. Okay. Alright. So that's the second method using zero product property. Now the third method is the one. It's the new method we and this belong to college algebra. This method we call the square root method. So this in the square root method, literally, actually, we have to do is we taking square root both sides. Okay, we're taking square root both sides of the equation, and it doesn't have to be in the form ax squared plus bx plus c. That's a good thing. Okay. It doesn't have to be in the form ax squared plus bx plus c. Okay, as long as on the left hand side is a perfect square, and as long as on the right hand side could be a perfect square, or it could be a prime number, or it could be anything, then you can take square root. You can take square root both sides. For example, what if I have this? What if I have x squared equals 64? Okay, So on the left hand side is a perfect square, right? And 64, okay, 64 is a square. Think about it. It's good because it's also the perfect square. So if I go ahead and take square root both sides, and when you take square root both sides, it's always give you plus minus. So square root of x squared, okay, and square root of 64 is plus minus 8, okay, because 8 times 8, 64, okay, 8 times 8, 64. Alright, remember that, okay, and negative times negative 8 also 64, so that's why we have to have plus minus. And if you notice, for all quadratic equation, we always have two solution, one solution, or repeated solution. I'm sorry, two solution, no solution. We don't have one solution. Two solution, one solution repeated, which is 2, and no solution. Okay. So if you have only one, that one must be repeated, so I count it as two solutions. Okay. So most of the time you have two different solutions. You see that? Plus minus. Okay. All right. How about this? Alright, look like it doesn't have the middle term, right? They have the square term, it doesn't have the y term, but they have the number. Alright, the same thing, you're gonna subtract both sides by negative 36, and you divide by 2, give you negative 18. And now you're gonna go ahead and take square root. And when you take square root like this, you remember the negative over here to become I square. So I can draw like this, right? And remember, when you take square root both sides, you always have plus minus, so we just give you I plus minus. Square root of I squared is I. We have to simplify square root of 18, so square root of 18 will be 9 times 2, so square root of 9 is 3. So you have 3i square root of 2 plus minus 3i square root of 2. Okay, because 18 is 9 times 2. Okay. Example 3. Okay. How about this? Alright, so this is a perfect square, but this is not a perfect square, so we still can take square root both sides. And this is throw away the square, so you have x plus 3. And this is give you plus minus. Square root of a is square root of 4 times 2, square root of 4 is 2. So there you go, and you have to subtract both sides. There you go. So you have two answers. The first answer is 2 square root of 2 minus 3. And the second one is negative 2 square root of 2 minus 3. They always have two distinct answers. Sometimes it's repeated, but most of the time it's two distinct answers. Okay. Alright. Okay. Let's see. Let's see what else. I can give you another one. Example 4. What do I have this? I have 2 x minus 5 squared plus 5 equals 23. Alright. Now, if you want to use quadratic square root method, again, you gotta bring it to the form something square in a number. You see that we get stuck with 5 and 2, so we cannot take square root both sides right now. So you gotta subtract both sides by 5 first, give you 18. Then you divide both sides by 2, which is give you 9. And now you see that you can take square root both sides, because on the left hand side is a perfect square, and the right hand side is a number. So right now you have x minus 5 plus minus 3. So your answer will be x plus minus 3 plus 5, which is 2 answer will be 8 and 2. There you go. So x equals 8, x equals 2. Okay, so remark, I'm gonna put a remark for here for you. So in order to apply square root method, the left hand side, okay, must be perfect square, must be a perfect square. Okay, by itself, which is you're not allowed to have a number in the front, you're not allowed to have a number after the perfect square. Okay, and again, this perfect square must contain x. Okay, okay, this perfect square must contain x. Okay, so the perfect square must contain um, x. Okay, and the other side is the number. So the other side is a number here. Okay, all right. Now the last method. Um, the last method is the hardest one, and as far as I know, many of you uh, won't like it, I'm sure. However, it's very useful and it works all the time. The reason it works all the time because in this method include the square root method. So I can say that the square root method is the baby version of this method. We call it complete the square. Okay. So method number 4, completing the square. Okay. Okay. And as you know, if a trinomial cannot be factored, it means that you cannot solve by zero product property. So that method doesn't work all the time. Quadratic formula work all the time, but that's just a very standard one. Completing the square is the new method you learn. Actually, completing the square is the process of deriving quadratic formula. You know the formula negative plus minus square root b squared minus 4 is equal to 8. That is actually, that formula, it comes from the process in completing the square. Okay, so completing the square work all the time. Of course, it's hard. It takes step. It takes longer, but it works all the time. Now I'm going to split it up into two cases. The first case is when the leading coefficient equal 1. Okay, the ax squared plus bx plus the a equal 1. For example, I have something like this. What if I have example 1. What if I have x squared minus 4x plus 5 equal to 0. Okay. So you see the a over here is 1. Now, in order to complete the square, because I just said a square root method is a baby version of completing the square. So in the process of completing the square method, we try to bring it to the perfect square so that we can apply the square root method. So in order to do that, the first step is you always have to kick c onto the other side. Okay, you kick c to the other side. Then okay, you're gonna take the number in front of the x, which is negative 4. You squared it. Oh, you divided by 2. I'm sorry. You take negative 4 divided by 2, which is negative 2, right? Negative 2 squared is 4. Okay, let me repeat it. You take the number in front of the x, always divided by 2. Okay, which is give you negative 2. Always, okay, always divided by 2. Then you square it. give you negative 2 square parentheses give you 4. So you're gonna add 4 both sides. Okay, so I use different color here so that you know where I get the number 4 from. You take negative 4. Let me do it on the side for you. You take negative 4. You divide it by 2, which is give you negative 2. Then you take negative 2, you square it, which is give you 4. Here you go. That 4 is right here. Okay, that's why we have 4. Okay, so you gotta do this on the side. Okay, now, so after we got this, right, this 3 term here, okay, I can write it as x minus, because this is minus, so we have right minus. Okay, minus what? Minus right here, right here, because 2 square. Alright, negative 2 square is that negative 2 then square. Okay, equal negative 1. Okay. Alright, now you see that this is I can take square root both sides. So I go ahead and take square root both sides. See, because this is perfect square, right? Okay, equal square root of negative 1. Square root of this I can throw it away. Square root of negative 1, which is square root of plus minus I. Okay, so x equal plus minus I plus 2. There you go. That's your answer. All right. Now let me give you another one. How about this? Yeah, the a is still 1. Okay, x squared plus 5x minus 7. Again, first step. Okay, first step, kick the c to the other side. Alright. Now, where we gonna get the number over here? So you take this, right? We do on the side. Okay. You take 5. You divide by 2, which is 5 over 2. Then you take 5 over 2. You square it, which is 25 over 4. There you go. That's the number. Okay, 25 over 4. So you add 25 over 4 here, and you add 25 over 4 over here. Then these 3 terms over here become x plus 5 over 2 square 5 over 2 then square. Okay. And over here I combine them. LCD 28, 53. Okay, over 4. Alright, now we can go ahead and take square root both sides. Okay, 53 over 4. And when you take square root both sides, you can throw away the radical. And this is give you plus minus 53 square root of 4 give you 2. So your answer will be plus minus 53 over 2 minus 5 over 2. Okay, so that's your final answer. 1 plus 1 minus. Alright. So that is the in the first 2 example here is for the case when a equal 1. What if a is not equal 1? Then you gotta do an extra step. You gotta do another step. Okay, you gotta do another step. Alright, so let's start with the second case. So if a is different from 1, okay, if a is different from 1, let me give you an example. When a is different from 1, what if I have this? What if I have alright, what if I have 5 squared minus 3x plus 1. Alright. See the a over here? A is 5, it's not 1. So again, the first step you still, in the case when a equal 1, right? The first step is you kick the number c to the other side, right? You subtract, you get rid of number c. But over here, usually we have to get rid of number 1, right? By subtracting both sides by 1. However, because we got to do another step before that, we got to convert this into 1. So I'm going to go ahead and divide both sides by 5 first. When you have to divide both sides by 5 first before doing anything else. Then you see that this is 1 now. And if it's 1 now, you can kick to the other side. Negative 1 here. Okay. Right. You subtract both sides by 1/5. Here you go. Okay. Now we're gonna take the value in front of the x, which is, let's do on the side, okay, which is negative 3 over 5. You divided by 2, right? Divided by 2, which is give you negative 3 over 10. Then you take negative 3 over 10, you square it, which is 9 over 100. Alright, so that is the number you put over there. 9 over 100. So I use different color. Okay, and then 9 over 100 here. Okay, then from here I can write it as, because it's minus 3 over 10, right? So you have x minus 3 over 10 and square. Okay, square. Minus 3 over 10 square. This 3 term here, you can convert it to this. Alright, this is give you negative 11 over 100. Right, it's added fraction. Okay. Now you can take square root both sides. Go ahead and take square root both sides. Right. And square root of negative number give you plus minus I, huh? You see plus minus I. And square root of 100 give you 10. And on the top we will have square root of 11, because 11 is a prime number, we cannot do anything else. So from here I got x equal 3 over 10 added both sides by 3 over 10 plus minus I square root of 11 over 10. There you go. Okay. So that's for the case when a is different from 1. You just have to do extra step, which is divide both sides by the a. Alright. Now what if your a is a negative number? You're gonna do the same. You're gonna divide both sides by the negative a. Okay, it's not a big deal. So you go ahead, divide both sides, give you x squared minus give you plus, minus give you plus. There you go. Because you don't want to deal with a minus, okay? There's a second option is you can go ahead and divide both sides by negative first. Then divide both sides by 2. Over here, I'm just go ahead divide both sides by negative 2. There you go. I can combine them. Then, alright, kick 5 over 2 to the other side. Then you take this term. Let's do on the side, okay? Take this term, 3 over 2. Okay, you divide it by 2, which is give you 3 over 4. And you take 3 over 4 square, give you 9 over 16. Here you go. So that is the number we're going to put it there. 9 over 16. 9 over 16. And this 3 term over here, I can write it as x plus 3 over 4. Right? Square. Equal 49 over 16. Right? Or add a fraction. Okay, everybody know how to add fraction. So now you can go ahead and take square root both sides. You have calculator. If you forget how to add fraction, you have calculator. Plus, just give you plus minus. Plus minus square root of 49 is 7. Square root of 16 4. Alright, then x equal plus minus 7/4 minus 3/4. So you have to answer, which is 1, and the other one should be negative 10/4, which is negative 5/2. There you go. So you have two answers. The first answer is 1, and the second answer is negative. Okay. Oh, I think I have careless mistake. It should be minus, because when you click it, it should be minus here. I'm sorry, guys. Instead of change like that, let's keep it like this. I'm going to change this to plus. There you go. Then change this to, you divide it, which is give you minus. There you go. It's easier. Alright. Then you have to answer. Alright, 1 and then 5. Okay. So that's the difference between when a equal 1 and a is not equal to 1. You just need to divide both sides by the a value. Then you see that it becomes 1. And it should be positive, okay? Because see, all the problem here is positive. If it is negative, you can divide both sides by negative. All positive. Otherwise, it's hard for you to complete the square. Okay. Alright. So that's so all the method we learned in this video. And you focus on completing the square method, because completing the square method definitely will be on the test. Of course, you must know the audio method too. It takes time for you to get used to the completing the square, so spend a little bit of time, okay, to practice, okay. And you can come up with your own quadratic equation and so by completing the square. Alright. So I think I'm gonna stop the video over here. If you have any question, please send me a message and let me know. Okay, I don't mind going through the step by step with you. Alright, I'll see you next time.